Who really controls the AI that speaks your native language? Think about it. It's a question that is quietly but absolutely defining the next decade of global technology. Right now, if you're using a language model in Rome, Madrid, or Berlin, you are almost certainly relying on a system built across the Atlantic. We're talking about systems designed with a distinctly English-first mindset, trained on mostly English data, and ultimately controlled by just a handful of massive tech companies. But what happens when a country decides they've had enough of renting their digital brains? What happens when they decide to build their own entirely from the ground up?
Welcome to This Explainer. Today, we are diving into a truly fascinating case study, Italy's massive bet on building its own AI from scratch. It's a project called Minerva. And as you'll see, while it represents the triumph of national coordination, it also delivered a really hard empirical lesson, one that the rest of Europe, and honestly the whole world, is now being forced to confront.
Here is our roadmap for today. We'll start with the sovereign AI dream, map out Italy's institutional blueprint, compare Minerva to Portugal's Amalia, look at the harsh Invalsi reality check, establish the new public benchmark standard, and finally wrap up with the pan-European pooling imperative.
Okay, let's jump right into Section 1, the sovereign AI dream.
So what do we actually mean when we throw around the term sovereign AI? Well, it means a nation doesn't just rent a generic American model wrapped in an API. It's about building a native speaking engine from the absolute ground up. That means using native computing infrastructure, a heavily weighted native language dataset, and, this is key, maintaining truly open weights. Why? So local researchers can audit the system and local regulators can actually verify it. It's really about total control over the cultural and technological artifact.
Moving right along to Section 2, Italy's institutional AI blueprint.
Italy didn't just talk about doing this, they built an incredible machine to actually pull it off, treating AI like critical national infrastructure. And, honestly, it's a brilliant, replicable blueprint for any country. First, you need leading academics. Here, Sapienza NLAP led the core research. Second, you need raw computing power. Sineca, which is Italy's national supercomputing consortium, stepped up with 128 GPUs on their massive Leonardo supercomputer. And third, you need funding. Through their post-pandemic recovery plan, the PNRR, the government heavily backed the FAIR consortium. They got academia, supercomputing, and government funding walking in absolute lockstep. It completely proves that post-pandemic PNRR funds can be a highly scalable framework for sovereign tech investments.
Now, the actual artifact this massive team-up produced was Minerva 7B. Most generic language models out there are, maybe 90% English and like 1 or 2% Italian if you're lucky. But Minerva, they trained it on 2.5 trillion tokens. Think of tokens as the little fragments of words an AI reads. A staggering 50% of that was Italian text. That is 1.14 trillion Italian tokens. They didn't just treat the Italian language as a fine-tuning afterthought, they made it a first-class citizen in the AI's core architecture.
They even took it a step further and built a custom tokenizer specifically for Italian. Look, when you try to use an English-centric tokenizer to process Italian, it's just super inefficient. By building a custom one, Minerva achieved a roughly 25% efficiency gain in processing Italian text. That literally means they save money and compute power every single time the AI speaks or reads. Operationally, that's just brilliant.
And they didn't stop there. They invested in over 20,000 manually curated safety instructions completely specific to the Italian cultural context. You can't just run English safety protocols through Google Translate and expect the model to catch Italian discriminatory speech patterns or those really subtle cultural nuances. Real alignment takes local experts, and Italy actually made that investment.
Section 3, Minerva versus Portugal's Amalia.
To really grasp the magnitude of Italy's strategy, we have to contrast it with what Portugal did. This comparison is absolutely crucial. Minerva took what we call the from-scratch path. They started with a totally blank slate, ate the massive compute costs, gathered over 1 trillion Italian tokens, and built that custom tokenizer. Portugal's Amalia, on the other hand, went with the continuation path. They took an existing foundation model, a pre-trained general AI brain called EuroLLM, and just layered on specialized Portuguese knowledge using about 5.8 billion tokens. Now, the continuation approach saves an immense amount of compute and money, but you risk not getting that deep specialization. Italy basically took the highly expensive long way around just to guarantee that depth.
Which brings us to Section 4, the Invalsi reality check.
So, by every institutional measure we just talked about, Italy's from-scratch approach was a huge triumph. Well, actually, scratch that. It was a triumph on paper. Then came the empirical reality check. They tested the Minerva 3B model on the Invalsi benchmark. Those are the actual standardized exams Italian students take. And it scored 4.9%. Let that sink in for a second. 4.9%. If a human student brought that grade home, there's no way they wouldn't be grounded. On a multiple-choice test, that's basically random chance. Despite the custom tokenizer, despite the perfect 50% Italian data mix, the model totally stumbled on deep, complex reasoning about Italian curriculum content.
The researchers who ran this evaluation hit the nail on the head. They noted that, quote, while the pre-training dataset composition is important, the overall size of the dataset and the number of parameters are more crucial for handling complex language tasks. This is exactly what the AI community refers to as the bitter lesson. You can optimize for a native language all day long, but at the end of the day, massive parameter counts, the billions of synthetic neural connections, and raw data volume are the absolute dominant variables when it comes to complex reasoning.
So here is the harsh takeaway. 3 billion parameters and 660 billion tokens, which was the scale of the Minerva 3B model tested here, it's just simply not enough to capture true country knowledge depth. Even with that perfect 50-50 data mix, smaller models hit a fundamental scaling wall. You just cannot shortcut your way around the massive computing power needed for advanced reasoning.
Section 5. The Public Benchmark Standard. Now, we shouldn't view that Invalsi score as a failure. It is actually a really vital, transparent revelation that changes exactly how we need to evaluate these sovereign AI models moving forward. If the whole point of a sovereign language model is to master local culture, we have to test it on exactly that. Sovereign LLMs must prioritize transparency by testing against public national curriculum benchmarks. We need to see how they perform on Italy's Invalsi, France's Baccalaureate, Spain's Selectividad, or the national exams in Sweden and Portugal. These tests actually measure the cultural depth these expensive projects claim to have, way better than any generic translated American benchmark ever could.
And finally, Section 6, the Pan-European Pooling Imperative.
If an individual nation's massive, brilliantly structured, and well-funded investment still falls short of frontier capabilities because of these scaling limits, we kind of have to rethink the entire continental strategy. We are looking at a really hard choice here. On one side, fragmented national efforts. They carry a huge financial burden, they hit fundamental parameter scaling limits, and they build a lot of redundant infrastructure across borders. On the other side, pan-European pooling, like the proposed Open Euro LLM initiative. By combining compute power across the entire continent and sharing massive datasets, Europe might actually have the scale to break through those parameter walls and genuinely compete with the massive models coming out of the US and China.
Which leaves us with a pretty provocative final thought. Italy provided an absolutely perfect institutional blueprint for sure, but the data and compute demands to reach top-tier reasoning are just so incredibly massive. So ask yourself, can any single European nation build a frontier-level sovereign AI entirely alone? Or, to achieve true AI sovereignty, must Europe trade individual national pride for collective continental scale? It's a question that's going to decide the future of technology on the continent. Thank you so much for joining me for this explainer, and I'll catch you in the next one.